Hello guys, and welcome to the Funny Documentary Channel. Tonight's story drifts outward toward a telescope resting far from home. The James Webb Space Telescope, whose deep gaze reveals a universe stranger, richer, and more intricate the farther it looks. Our topic is, the further James Webb looks, the stranger space becomes. It's a title that hints at mystery, but the mysteries tonight are gentle ones. Soft-edged puzzles meant not to stir the mind, but to soothe it. So find a comfortable position, let your breathing slow, and allow the day to fade behind you. We'll begin a slow exploration through time, light, and the quiet strangeness woven into the fabric of the universe. A journey designed for rest, for drifting thoughts, and for easing into sleep as the cosmos unfurls around us. Now, before we settle into tonight's quiet journey, I invite you to like this video, subscribe to the channel, and leave a comment sharing when and where you're listening from. Some people join us at the end of a long day, others during a restful afternoon, and many drift in from time zones scattered across the world. Wherever you are, your presence here helps shape this calm little corner of the cosmos. Let's begin. It is difficult to speak of the James Webb Space Telescope without first acknowledging the quiet persistence that brought it into being. Not the loud, triumphant persistence of dramatic countdowns or roaring engines, but the softer kind. Patient engineers, late-night desks, and the slow, steady rhythm of ideas returning again and again until they fit. Webb was never a sudden creation. It was something assembled in thoughtful increments, as though the universe were allowing humans to build a small, gold-plated question and send it outward with the hope it might return carrying an answer. For more than 2 decades, the telescope lived in pieces. Not broken pieces, just unfinished ones. A mirror here, a cooling system there, all waiting to meet each other. It spent years, not in the vacuum of space, but on quiet tables, behind structured cleanroom walls, where technicians moved with the same careful pace one uses around a sleeping animal. Everyone seemed to understand that a telescope meant to look back more than 13 billion years required a particular kind of calm during its creation. It was not something to be hurried. It would, after all, be spending its life observing light that had been traveling since long before humanity existed. A few extra years on Earth were unlikely to trouble it. Even when Webb finally left the ground, it did so without theatrics. Rockets can be dramatic, yes, but the telescope itself remained folded and inward, as though preserving its energy for the work ahead. Once freed from the cradle of its launch vehicle, it drifted gently toward a gravitational balance point known as L2, a place where the sun and Earth pull with just the right combination of forces to let an object rest almost effortlessly. It's an elegant piece of celestial architecture, a sort of quiet balcony overlooking the solar system, and there, 1 million miles from home, Webb unfolded. This unfolding was not quick. It was a slow, deliberate unwrapping, like a thoughtful creature stretching after a long sleep. Engineers had designed the mirror segments to open with extraordinary caution, each hinge and actuator moving at a pace that would make even a glacier feel hasty. No part of Webb moved with speed. It simply settled into place, piece by delicate piece, unsure of the attention it was receiving, but uninterested in performing for it. By the time the mirror took its final shape, a wide hexagonal bloom glowing softly in the sunlight, the telescope had already demonstrated the personality it would keep for the rest of its life. It was steady, intentional, a machine that worked not by force but by quiet certainty. Unlike many devices humans build, Webb showed no desire to impress through activity. It preferred stillness, knowing that stillness was essential for its purpose. Once Webb reached its observatory position, Earth grew small behind it, a faint blue memory tucked at the edge of vision. The telescope carries no awareness of home, of course, but there is something poetic in imagining its gold mirrors, noticing the planet shrinking, acknowledging it with the faintest nod, and then turning all attention outward. It had waited long enough to begin. The moment its instruments cooled and the mirrors sharpened into alignment, the telescope finally opened its eyes. The view waiting for it was not a surprise to astronomy, but it was a reminder of why the universe is so difficult to describe. Even the empty parts are full of things. Webb approached this reality with a quiet sort of acceptance. It had not been launched to find simple scenes. It had been launched because the cosmos is thick with questions too large to fit comfortably inside any single human mind. And yet there is a humility in Webb's design that deepens its charm. This machine, capable of observing the faintest whispers of light from the early universe, works by gathering details so subtle they almost refuse to be seen. It listens to infrared signals stretched by immense distances and immense time, reading them without complaint. If light arrives tired after traveling billions of years, Webb does not mention it. It simply receives what is offered, decoding the long journey with a calm, methodical grace. There is something quietly humorous, too, in how this entire telescope, massive, brilliant, technologically complex, successfully operates only because it avoids warmth. A single degree too warm and its vision would blur, so Webb stays cold, unreasonably cold, cosmically cold. It spends its days in temperatures that would make a snowflake reconsider its life choices, and it seems perfectly content, as if it always preferred the serene chill of deep space over the energetic bustle of Earth. From its resting place at L2, Webb does not orbit the Sun in the traditional sense. It drifts in a subtle looping pattern around a gravitational saddle point, held gently, almost politely, by the balance of forces. It is the cosmic equivalent of sitting on a quiet porch where the universe's breeze maintains your chair at just the right angle. Nothing rushes, nothing pushes. The telescope simply remains. And that is how Webb begins, not with discovery, but with composure. It starts its mission the same way a deep thinker begins a long reflection, by settling into a position of comfort, letting the noise fall away, and opening itself to whatever truths might drift through the silence. The galaxies will come later. The strange, luminous knots of the early universe will reveal themselves in time. But before any of that, there is this moment of stillness, a telescope resting far from home, perfectly positioned, perfectly patient, ready to listen to light older than memory. This is where the story truly begins, not with the mysteries Webb uncovers, but with the patience it carried long before its first image ever reached us. There is a quiet strangeness in the way the universe handles distance. On Earth, distance is ordinary, a stretch of road, a widening field, a shoreline drifting farther from reach. But in space, distance rearranges itself into something more intricate. It becomes time. It becomes memory. It becomes a kind of gentle anachronism, in which the farther something is, the younger it appears. not because it is trying to look youthful, but because its light has simply taken that long to arrive. The James Webb Space Telescope works in this unusual reality as though it were the most natural thing in the world. It points toward a patch of sky that looks still and empty to the unaided eye, and patiently collects the light that has been traveling for billions of years. To Webb, this ancient light is not mysterious or dramatic. It is just delayed. Great distances tend to do that. A photon that left a young galaxy long before Earth formed eventually completes its marathon, drifting into Webb's instruments with the weary dignity of something that has seen too much and refuses to brag about any of it. The reason time becomes so tangled with distance is rooted in the expansion of the cosmos. Everything drifts apart, not quickly, not abruptly, but slowly and steadily, like a deep breath taken over billions of years. As space stretches, the wavelengths of traveling light stretch with it. Colors shift. Blues relax into reds. Reds lengthen until they slip beyond the reach of ordinary human perception. By the time these stretched out signals reach us, they are no longer the bright, energetic photons they once were. They are softer, quieter, tinged with the long patience of the journey. This is precisely why Webb was built to see in infrared. Infrared is the language of ancient light, the place where exhausted photons lie down to rest. The telescope reads these softened signals without judgment, revealing galaxies that look less like they are hiding and more like they are arriving fashionably late to a cosmic gathering. Whether they meant to be late is unclear. The universe has never been known for punctuality. When Webb gazes deep into space, it performs a kind of chronological unspooling. Objects closer to us appear, as they are now, stars steadily burning, galaxies swirling in their calm, spiral routines. But as the view extends outward, a subtle shift begins. The modern universe fades, replaced by earlier and earlier eras. Entire epochs unwind in reverse. A point of faint light becomes not something far away, but something long ago. A message whispered across the ages by a source that no longer resembles what the telescope sees. In this way, Webb does not merely observe, it travels backward without moving at all. Space offers it this paradox effortlessly. Light behaves like a messenger who started running before humans learned to walk, delivering news from a past that none of us witnessed. One could imagine that these photons originally set off with a sense of purpose, only to discover midway through the journey that the universe was expanding beneath them. They stretched, adapted, and kept going. If they were frustrated by the delay, they hid it well. This relationship between distance and time also means that Webb's deepest images become a layered diary of the cosmos. Each point of light occupies its own page, its own century, its own state of becoming. Some galaxies sparkle with youthful brightness. Others carry the faint blush of stars just beginning to gather. In a single image, billions of years lie side by side as if the universe kept all its ages open at once. There is something quietly humorous about this arrangement. Humans spend so much time organizing events chronologically. Tidy sequences, clean timelines, and the universe simply refuses. Its history does not appear in order. It appears all at once, scattered across the heavens in a pattern that makes sense only if one accepts that the cosmos is far too large to behave tidily. If the universe had an opinion about this, it might shrug and suggest that anyone expecting efficiency from something 90 billion light-years wide is being unrealistically optimistic. Yet, in this vastness, there is comfort. Distance as time smooths out the edges of cosmic history. Nothing rushes, nothing interrupts. The earliest stars do not shout for attention. They glow gently, knowing their voices have traveled long enough. Even the galaxies forming in the distant past seem to behave with unhurried purpose, unconcerned that their light will not be intercepted for billions of years. If they had schedules, they lost them long ago. For Webb, this temporal layering becomes a way of listening. Each observation is a conversation with a different moment in the universe's life. Some moments young and chaotic, others mature and settled. The telescope does not force these eras into alignment. It simply receives them as they come, letting the past and present coexist without conflict. And in this quiet exchange between telescope and time, the universe reveals a truth that feels both enormous and soothing. Distance is not emptiness. It is history stretched thin. It is memory drifting. It is the long echo of creation carrying itself forward in whatever form it can manage. Looking outward, Webb becomes not an explorer of space, but a reader of old light. Light that reaches us not in urgency, but in patient continuity, still glowing from a universe that has never stopped growing older. Even as its earliest chapters continue traveling toward us, one softened photon at a time. The earliest images released from the James Webb Space Telescope possessed a strange dual nature. At first glance, they seemed comfortably recognizable. Points of light, arcs of color, wisps of gas suspended in darkness. A seasoned astronomer could scan them and say, yes, this resembles what we've seen before. But then, almost immediately, something shifted. A second glance revealed features that didn't quite align with expectation. Galaxies, too luminous, too formed, too confident in their own existence long before they were supposed to look this way. It was the celestial equivalent of a historical painting where a figure in the background is inexplicably checking a wristwatch. These early images behaved the way a polite guest might behave upon entering a room. They introduced themselves gently, waited for a moment of recognition, and then began rearranging the furniture. Models of early galaxy formation held assumptions about what the universe should look like at various stages of infancy. How bright the first galaxies ought to be, how large they could become, how quickly stars had time to gather. Webb, however, revealed objects that seemed to have ignored the anticipated timeline entirely. They existed with a composure that suggested they had always been there, and any schedule constructed by humans was simply a suggestion. Scientists accustomed to predictable observational patterns found themselves pausing. These galaxies did not violate physical laws. They simply stretched them, bent them, and played with them as though testing their flexibility. Some of the earliest objects Webb captured had the luminosity one might expect from galaxies hundreds of millions of years older. Yet there they were, shining calmly from an epoch when cosmic conditions should have been much harsher. It was as if the early universe had taken one look at the rule book of galaxy formation and, in a moment of quiet rebellion, decided to improvise. One of the more subtle surprises in these images came from how densely populated they appeared. Regions of space, thought to be sparsely sprinkled with early structures, were suddenly filled with them. Galaxies seemed to cluster like guests at a gathering that had been scheduled to start far later in the evening. They were not rushed. They were simply early, glowing with the quiet self-assurance of entities that had never concerned themselves with human expectations of cosmic pacing. Even their shapes carried an air of unexpected maturity. Instead of appearing as loose, chaotic gatherings of newly formed stars, many galaxies possessed well-defined structures, rounded bulges, elongated forms, faint hints of rotational order. These shapes suggested processes already underway: gravity settling, material cooling, stars finding their long-term homes. This was supposed to be a universe still fumbling its way through the basics, yet it presented itself with the confident posture of something that had skipped a few steps. Theories adapted, of course. They always do. Science is not rigid. It is quietly flexible, adjusting itself with the patience of a system accustomed to occasional surprises. But there was a certain humor in watching the early discussions surrounding Webb's first images. Astronomers, typically measured in tone, spoke with an unmistakable air of polite confusion. Phrases like unexpectedly bright, unexpectedly massive, and unexpectedly numerous began appearing with predictable frequency. One could imagine the early universe listening to these reactions and responding with a gentle, indifferent shrug. An especially intriguing feature of these images was the presence of objects whose colors suggested extremely high redshifts. Signals stretched so dramatically that their origins pointed to epochs very close to the birth of galaxies themselves. Yet many of these objects sparkled with an intensity that implied efficient star formation, or perhaps even unusual concentrations of early material. These were not the faint, tentative structures many expected. They were bold, luminous, and seemingly unbothered by the fact that they were shining across more than 13 billion years of cosmic distance. Webb, for its part, did not interpret these anomalies. It merely observed. It captured light unwaveringly, transmitting image after image without commentary. If the telescope had a personality, it would be the sort that delivers enormous surprises with absolute calm, the kind of companion who casually mentions that the universe might be more complicated than assumed, and then quietly returns to its work. The mismatch between expectation and observation was left to humans to puzzle over. In reviewing the images, one could sense a deeper undercurrent as well. The universe has always been slightly disobedient. Not dramatically so, no wild departures from physics, but subtly, persistently willing to test boundaries. Webb's early images reminded scientists that even the most carefully constructed models are, at best, translations of cosmic behavior into human terms. The universe itself remains the original text, and occasionally it chooses to revise a sentence. The misbehavior, however, never felt malicious or chaotic. It felt playful in a cosmic sense, a gentle insistence that the universe is richer, stranger, and more intricate than any diagram can capture. The galaxies Webb revealed were not anomalies in the disruptive sense. They were simply honest. They showed themselves as they were, not as they were expected to be. This honesty produced a peculiar kind of beauty. Each image held not just light, but the quiet thrill of realizing that the universe still keeps secrets. Secrets not guarded fiercely, but held loosely, waiting for an observatory patient enough to notice. Webb happened to be that observatory. It looked deeper and with greater clarity than anything before it, and in doing so, it exposed the early universe as a place bursting with activity, more energetic, more populated, more luminous than anyone had predicted. The result was a moment of delightful scientific humility. Theories would adjust, simulations would grow more complex, explanations would arrive in time. But before any of that, there was this simple truth. The universe had misbehaved gently and gracefully, and the first images of the James Webb Space Telescope had captured that moment with exquisite clarity. When the James Webb Space Telescope settled its gaze upon the earliest epochs of the universe, astronomers expected to find cosmic infants, galaxies in their first uncertain steps, uneven and loosely assembled, composed of young stars still negotiating their orbits. Instead, Webb revealed something far stranger: galaxies from the universe's earliest chapters that seemed to carry themselves with the poise of much older systems. They were compact, yet luminous, organized, yet youthful, as though the cosmos had chosen to move through its formative years at a pace too quick for the modern observer to fully grasp. These galaxies did not display the tentative structures one might anticipate from cosmic youth. Instead, many appeared densely packed, their stars gathered close together in tight configurations. Their shapes, smooth ellipses, soft disks, or bright central clusters, hinted at gravitational maturity. One could almost imagine them standing a little taller than expected, projecting an air of, yes, we've been here for quite some time, despite the cosmic record suggesting otherwise. Their luminosity was especially intriguing. Light from such early objects should, by most reasonable expectations, be modest, a gentle glow from stars only recently ignited. Yet Webb detected galaxies shining with surprising intensity, as though the stars within them had formed with remarkable efficiency. This brightness did not come from dramatic outbursts or cosmic theatrics. It came from quiet, steady radiance. These galaxies seem to have embraced their roles early, choosing not to linger in infancy. The compactness of these ancient galaxies added another layer of mystery. Rather than sprawling arms or loosely connected clusters, they displayed tightly bound cores, their stellar populations packed into regions far smaller than those of modern galaxies. In some cases, they resembled shimmering knots of light rather than sprawling star cities. This density implied a period of rapid gathering, as if gravity had worked overtime, drawing matter inward with unusually determined focus. It's the kind of behavior one might expect from a universe eager to get organized long before anyone anticipated such enthusiasm. There is a touch of cosmic humor in this. Humans tend to imagine the early universe as chaotic, messy, and unrefined, a place where galaxies fumble their way into existence, much like toddlers learning to balance. But Webb paints a different picture, one where ancient systems appear oddly composed. It's as though the universe had a burst of early confidence, constructing entire galactic neighborhoods before modern cosmologists even finished drafting the architectural plans. Some of the most intriguing early galaxies showed signs of rotational structure, hints that they were already spinning in coherent patterns. Rotation is not something galaxies achieve quickly. It emerges through complex interactions as material settles into gravitational harmony. Yet here were early systems already displaying the first graceful turns of cosmic choreography. They didn't spin wildly or fancifully. They rotated with a quiet sense of purpose, the kind one associates with galaxies that had already lived long enough to know what they were doing. Their chemical compositions added another layer of fascination. While not rich in elements forged in later generations of stars, some of these systems contained heavier atoms earlier than anticipated. This suggested that star formation was not only rapid, but also abundant, producing enough stellar generations to begin enriching the surrounding medium. The universe, in these corners at least, seemed to have been industrious from the very start, building complexity without pausing to explain its reasoning. The variety among these mature-looking galaxies was equally striking. Some were smooth and compact, like softly glowing beads. Others showed faint hints of structure beginning to stretch outward. Incipient arms, gentle elongations, the earliest whiffs of galactic personality. None appeared clumsy or unformed. They existed with an air of completion, even though they belonged to a cosmos, barely stepping out of its earliest expansions. Webb's role in revealing these systems was not one of exaggeration or distortion. It simply observed with clarity that previous instruments could not achieve. The telescope's sensitivity allowed it to capture faint, ancient light with remarkable precision, turning distant glimmers into detailed portraits. In doing so, it overturned the comfortable assumption that early galaxies should look small, dim, and chaotic. Instead, Webb showed them as confident, assembled presences, galaxies that had apparently chosen to mature early and never bothered to announce their intentions. One could imagine the universe offering a quiet explanation for this, something like, "I had a lot to do and limited time to do it." But in truth, the behavior of these galaxies reflects deeply complex physics, rapid cooling, efficient star formation, early gravitational wells pulling matter into dense regions, and a young cosmos filled with raw material ready to ignite. Nothing here violates natural law. It simply moves with unexpected swiftness. The surprise lies only in how gracefully these galaxies seem to have handled the process. For astronomers, these discoveries sparked not frustration, but curiosity, a sense that the universe once again had expanded the boundaries of what was considered possible. Models would adapt. Simulations would grow more sophisticated. New theories would attempt to trace the pathways through which such early maturity might arise. But beyond all scientific implications, the images hold a softer truth. The early universe, despite its youth, contained structures that already carried themselves with an air of cosmic adulthood. They glowed not like fragile newcomers, but like systems quietly aware of their place in the unfolding story of creation. And so, Webb revealed ancient galaxies that looked remarkably grown up, galaxies that skipped the awkward years, stepped confidently into existence, and left the rest of us to marvel at how effortlessly they seemed to manage it. When the James Webb Space Telescope opens its instruments to the cosmos, it does not peer into the universe that human eyes are accustomed to. It looks into a softer, subtler universe, one woven from wavelengths too long for ordinary vision to grasp. This is the domain of infrared light, a realm where brightness behaves differently and structures hidden behind veils of dust step calmly into view. It is not a universe newly illuminated. It is a universe that has always been present, simply waiting for the right kind of observer. Infrared light carries a distinct personality. It does not rush. Its wavelengths stretch leisurely across space, slipping through obstacles that would easily scatter or absorb visible light. When starlight travels through clouds of gas and dust, the shorter wavelengths, aquas, violets, hard whites, are stopped or redirected, leaving dark silhouettes. But infrared glides through with an almost meditative patience, arriving intact on the other side. The effect is transformative. Regions once thought empty or opaque reveal themselves to be busy places, full of quiet structure and activity. Webb's instruments were designed precisely for this gentle pursuit. They do not demand light, they invite it. The telescope's mirrors and sensors capture the faintest heat signatures from distant objects, assembling them into images that appear at first unreal. Nebulae branching in delicate filaments, star clusters shining through formerly impenetrable dust, planets glowing faintly around distant suns. But these visions are not inventions. They are the true colors of invisible light, translated into hues that human perception can accept. One of the remarkable consequences of infrared observation is the dissolution of darkness. The term dark often misleads, suggesting an absence of anything at all. Yet in the infrared, darkness behaves more like a mask, thin, removable, and surprisingly full of detail once lifted. Dense star-forming regions once cloaked in shadow become translucent under Webb's gaze. Newborn stars appear in place of emptiness. Cold structures, previously hidden, glow with just enough thermal energy to be seen. It is not that the universe suddenly becomes brighter. It is that the telescope listens to a different kind of light. Infrared also reveals temperature in a way visible light cannot. Warmth, even faint warmth, becomes shape. It becomes contour. It becomes a quiet announcement of presence. A star in its early stages does not yet blaze visibly, but its heat betrays it. A planet orbiting close to its star may not reflect enough visible light to appear in a photograph, but it radiates just enough infrared glow to be recorded. Even distant galaxies, stretched to the limits of visibility, emit softened warmth that Webb can gather gently into focus. Dust, cosmic dust, not the household variety, responds to infrared with a peculiar honesty. In visible light, dust clouds appear as heavy silhouettes, sprawling across the sky like smudges on a lens. But dust in infrared becomes illuminated, not because it is bright, but because it allows brightness to pass through. Webb sees not obstruction, but architecture. The shapes of distant nebulae reveal their internal folds and hollows. Filaments once opaque now show their delicate branching. Dust no longer blocks, it outlines. There is a quiet humor in how infrared light behaves if one listens closely enough. Visible light is dramatic, colorful, energetic, insistent. It displays what wishes to be seen and shadows what prefers privacy. Infrared, by contrast, is politely persistent. It does not pry or barge through. It simply navigates around obstacles with slow grace, arriving at the far end as though nothing had stood in its way. If visible light is a spotlight, infrared is a soft lantern carried at night, low, warm, and revealing only what needs to be known. Webb's ability to detect faint infrared signals allows it to study the coldest structures in the cosmos. Brown dwarfs, for instance, objects too massive to be planets but too small to ignite as stars, emit little visible light. Yet in the infrared, they glow with subtle warmth, small embers in the vastness. Molecular clouds, chilled nearly to absolute zero, nonetheless produce heat signatures that Webb can detect. Even ancient galaxies, stretched by cosmic expansion until their light has moved beyond visible wavelengths, still glow just enough to leave a trace that Webb can read like a distant memory. Infrared also plays a quiet role in revealing motion. Shifts in wavelength hint at gas drifting, stars forming, and interactions unfolding. A cloud may appear static in ordinary light, but in the infrared, currents and flows become apparent. Webb observes these changes not as dramatic events, but as gentle transitions, like watching the tide move across a quiet shore, slow enough that one must pay careful attention to notice. Perhaps the most striking aspect of infrared vision is how naturally it expands one's sense of what the universe contains. There is a comforting illusion in thinking that darkness defines boundaries, that what cannot be seen does not exist. But Webb's observations gently dissolve this illusion. The telescope shows that the cosmos is not sparse or silent. It is layered, textured, and busy in frequencies human eyes were never equipped to witness. The universe does not withhold its details. It simply speaks in wavelengths we have only recently learned to hear. As Webb continues to observe, it reveals a cosmos composed not of empty voids, but of subtle, persistent light. A universe where even the faintest objects contribute to the quiet glow that permeates space. A universe in which darkness is not an absence, but a threshold, waiting to be crossed by those patient enough to follow infrared light into the deep and gentle structures it illuminates. And so, through Webb's calm and unhurried vision, the universe begins to show its hidden colors, colors that were always present, simply living beyond the reach of ordinary sight, waiting for a telescope that could finally see them as they truly are. Within the great expanses of the cosmos, there are regions where stillness and activity coexist in an unusual harmony. These are stellar nurseries, enormous clouds of gas and dust where stars quietly begin their long lives. To the unaided eye, such regions appear opaque or featureless, more like cosmic smudges than anything resembling a cradle for newborn suns. But for the James Webb Space Telescope, these regions are full of gentle motion, subtle heat, and slow-building structure. Webb does not simply glance at them. It lingers, observing their transformation with the patience that only a telescope stationed 1,000,000 miles from home can truly afford. Inside a stellar nursery, gravity is the quiet architect. It does not shout or demand attention. Instead, it encourages gas to gather in soft accumulation, drawing particles toward one another with a persistence that borders on affectionate. The process is slow, so slow that calling it progress feels almost too energetic. Yet, over immense spans of time, these wandering particles settle into denser pockets, forming knots of material that will eventually ignite into stars. It is the cosmic equivalent of watching dew collect on a leaf, gentle, inevitable, and entirely without haste. Webb's infrared instruments reveal the interiors of these nurseries with exceptional clarity. The dust that normally conceals them becomes transparent, and the telescope sees intricate shapes sculpted by competing forces. In these quiet theaters of formation, structures rise out of the shadowed gas, long pillars shaped by radiation, arches carved by stellar winds, and pockets where temperatures drop low enough for complex molecules to gather. The scenes are delicate, almost tender. If one were inclined to assign personality to the cosmos, these nurseries would feel like the places where the universe whispers rather than speaks. The earliest stages of star birth begin in cold regions where gas is dense enough to collapse under its own weight. Webb watches as these areas deepen into rounded cores, faint, warm signatures indicating the subtle accumulation of energy. These forming protostars are not yet bright, not yet dramatic. They glow softly, the warmth of their contraction radiating outward. It is a type of light that seems hesitant to announce itself, as though the stars are modest about their beginnings. As material continues to fall inward, the protostar grows hotter at its center. But even then, the process retains its unhurried pace. Nothing leaps or bursts. Nothing demands to be noticed. A star's formation is a negotiation between gravity pulling inward and pressure pushing outward, a slow equilibrium establishing itself molecule by molecule. Webb captures the faint thermal signatures of this balance, watching as the protostar shifts from shapeless glow to something more defined. It is the astronomical version of watching someone slowly wake up, stretch, and realize they have a role to play in the world. The disks of material surrounding these young stars add further layers of quiet complexity. These protoplanetary disks, thin and delicate, contain dust grains that drift, collide, and gradually grow. Though the chapter of planets unfolds elsewhere, their earliest chapters begin here, in the stillness surrounding the newborn star. Webb detects patterns and rings within these disks, structures shaped by gravity, radiation, and gentle turbulence. In visible light, such disks vanish entirely. In the infrared, they shine like halos, faint but unmistakably present. Inside the nursery, cooler regions lie alongside warmer ones, each telling a different part of the story. Webb observes filaments of gas stretched by ancient shock waves, areas where radiation from older stars remodels the landscape, and voids where material has already been consumed. There is no uniformity to these places, no single rule governing their architecture. They are shaped by countless interactions, each subtle, each contributing to an environment where stars can emerge with surprising consistency. A soft humor arises from the sheer slowness of it all. Humans often imagine cosmic events as dramatic explosions or rapid transformations. But star formation is far more patient than that. If newborn stars possess personalities, they might be the type who spend a very long time deciding when to get out of bed. They gather their material, adjust their temperature, and only after a few 100,000 years consider shining properly. It is difficult to call this enthusiasm, yet it is undeniably effective. Webb's role in these nurseries is not to intervene or accelerate anything. It simply observes with clarity and humility. It watches light that is dim, cool, and easily lost in noise. It records the shapes of hidden structures with the precision required to tell where gravity is strongest, where material pools, where radiation carves its paths. And in doing so, it reveals that star formation, far from being a violent event, is a gentle unfolding, a long, slow settling into form. The beauty of these nurseries lies not only in what they create, but in how they create it. Stars are born in the quietest corners of the cosmos, surrounded by dust that softens even the faintest flicker of light. Webb allows us to see this softness, to understand that the universe builds its most luminous structures in places where patience is the primary ingredient. In these cosmic cradles, the universe shows that creation does not require urgency. It requires time, gravity, and an environment where light can begin its long journey outward. And so, among sprawling clouds shaped by forces older than any star within them, Webb witnesses the steady rise of new suns, quietly forming, gently glowing, and preparing for the lifetimes ahead. When most people imagine galaxies colliding, They picture spectacular destruction, stars smashing into one another, cosmic debris flying, shock waves rippling dramatically across space. But the universe is subtler than that and far more patient. A galactic collision in reality is an event so slow and so spacious that it feels less like chaos and more like a long drifting dance. Stars rarely meet head-on. The distances between them are vast enough that even in a collision, each one passes quietly by, unbothered, as though politely sidestepping a stranger in a wide hallway. The James Webb Space Telescope observes these encounters not as explosive battles, but as transformations stretched across hundreds of millions of years. Webb's infrared eyes trace the faint arcs of gas being pulled into new shapes, the soft glows of star formation kindled by gravitational tides, and the delicate bridges of material connecting one galaxy to another. Nothing about these interactions is hurried. They unfold at a pace so gentle that entire species could evolve and vanish before a single dramatic change becomes visible. When two galaxies begin their long approach, gravity starts the conversation. A slight pull here, a subtle tug there, nothing abrupt, nothing startling. Over time, their outer regions feel the influence first. Gas clouds stretch, spiral arms distend, and faint streams of material begin to drift outward like fabric caught in a breeze. These are the early gestures of the encounter, small acknowledgments that another massive presence has arrived. As the galaxies draw closer, their shapes warp in intricate, unhurried ways. Stars at the edges follow elongated paths, looping into tidal tails that reach across space like fingers brushing another's hand. These tails are not violent features. They are graceful extensions sculpted by gravity's patient artistry. Webb observes them glowing softly, illuminated by scattered star clusters forming within the stretched material. The brightness is gentle but unmistakable, evidence that even in the midst of upheaval, new stars find places to emerge. Contrary to instinct, the galaxies do not merge quickly. They pass by one another first, drifting through each other's edges, overlapping briefly in a shimmering superimposition of starlight. During this passage, gravitational forces reshape their structures further. Disks twist, cores bend toward one another, clouds of gas compress just enough to trigger pockets of star formation. Yet all of this happens without sound, without forceful collision, only slow rearrangement guided by the steady pull of mass. After their initial encounter, the galaxies drift apart again, trailing long threads of material behind them. The encounter is not finished, merely paused. Over millions of years, gravity draws them back for another pass, and then another. Each approach reshapes them further, smoothing some features, enhancing others. Their original identities begin to blur, and a new combined structure gradually takes form. Webb's observations of interacting galaxies show the full range of these transitions. Some pairs appear in their early stages, barely influenced by one another, except for faint distortions at their edges. Others are deep into their merger, with cores spiraling closer, gas clouds swirling in complex flows, and star bursts igniting at the points of greatest compression. And then there are systems that have nearly completed their transformation, settling into a single, larger galaxy, whose shape carries hints of both original components. Like a blended memory, perhaps the most surprising aspect of galactic collisions is their sense of calm inevitability. There is no resisting the process once gravitational attraction begins its work. Yet there is also no urgency. The galaxies simply follow where physics leads them, drifting through stages of interaction with a serenity that belies their size. If one were to imagine them as living beings, they would seem almost contemplative, aware of their transformation, yet entirely untroubled by it. Gas, rather than stars, often bears the most dramatic effects of these encounters. Unlike stars, gas clouds can collide, compress, and reshape. Webb captures these shifting landscapes in exquisite detail, glowing knots where new stars ignite, dark filaments collapsing into brighter regions, and vast rippling patterns as material redistributes. Even here, the changes occur slowly. Star formation triggered by collisions can take tens of millions of years to unfold, a time scale so long it feels almost like a slow inhale. Humans tend to think of collisions as destructive, but in the universe, they are often creative. Many galaxies owe their shapes, their richness of stars, and even their central structures to ancient mergers. Elliptical galaxies, rounded, smooth, and densely populated, often form from the blending of once spiral systems. Some barred spiral galaxies appear to have acquired their central bars through past interactions. The very structure of the Milky Way hints at such a history, and its future almost certainly includes a quiet merger with the Andromeda Galaxy, billions of years from now. Even that event, dramatic on paper, will feel more like a slow reorganization than a cataclysm. Webb's contribution to understanding these collisions lies in its ability to see the hidden components of the process. It reveals the warm dust heated by star formation, the faint glow of interacting gas, and the subtle gravitational distortions that might otherwise remain invisible. It uncovers the quiet choreography of galaxies reshaping themselves across time. In this gentle cosmic dance, one lesson emerges clearly. The universe prefers transformation over destruction, reorganization over rupture. Galaxies meet and merge not with violent fury, but with the composure of entities following a very old, very patient script. Webb observes these changes from its distant vantage point, watching galaxies drift, fold, and settle until new shapes emerge, shapes that will themselves continue wandering through space, waiting for the next long, graceful interaction in a universe that never truly stops rearranging its furniture. Among all the unexpected discoveries offered by the James Webb Space Telescope, few feel as quietly astonishing as the early appearance of supermassive black holes, colossal gravitational wells already active at times when the universe itself was barely old enough to understand what structure meant. These early black holes do not announce themselves with menace or melodrama. They behave with calm certainty, like engines that switched on at the dawn of cosmic time and settled immediately into steady, unstoppable work. Their presence raises soft but persistent questions. How did such massive objects assemble so quickly? What circumstances allowed gravity to gather matter into such dense configurations long before galaxies had finished shaping themselves? Webb does not answer these questions directly, but it provides the clues. Faint, reddened signatures of gas, spiraling inward, radiation escaping from the edges of swirling disks, and subtle distortions in the surrounding starlight, where gravity exerts its quiet influence. These signals reveal black holes not as cosmic anomalies, but as early participants in the universe's story, present from the beginning, with a sense of purpose that feels both mysterious and oddly pragmatic. In Webb's deep field observations, some of the earliest galaxies exhibit signs of energetic centers, regions shining too brightly, too compactly, or with spectral fingerprints that hint at intense heating. Such characteristics often point to what astronomers call active galactic nuclei, or AGN, black holes surrounded by swirling disks of infalling material. As gas spirals toward the event horizon, it heats dramatically, producing a glow that can outshine every star in the host galaxy combined. The light Webb captures from these early AGN has traveled across more than 13 billion years, carrying with it the evidence that black holes were already fully operational when the universe was still in its cosmic youth. What makes this surprising is not the existence of black holes themselves. They are quite natural outcomes of massive stars ending their lives or dense regions of matter collapsing under their own weight. What is surprising is their size. Some of the black holes identified in Webb's observations appear to possess millions or even billions of solar masses, far larger than simple collapse scenarios can easily explain within such a short cosmic time frame. They seem to have grown rapidly, gathering material with an appetite that was both sustained and surprisingly well organized. Yet, despite their formidable nature, there is nothing chaotic about these early black holes. Their accretion disks, the swirling structures of gas and dust around them, form elegant spirals shaped by gravity and magnetism. The radiation emitted from these disks spreads across space with quiet persistence. Even jets, when present, emerge not as explosions, but as steady beams of energetic particles, pointed outward with remarkable precision. These black holes do not behave like unruly cosmic storms. They behave like engines, humming along efficiently, neither rushing nor hesitating. Webb's infrared capabilities make it particularly well suited to studying these systems. Much of the visible light from early AGN is dimmed or absorbed by surrounding gas, but infrared wavelengths slip through, carrying clear impressions of temperature, motion, and composition. This allows Webb to uncover black holes whose signatures were previously hidden, revealing a population that was once only faintly suspected. The faint glows emerging from these early cosmic centers tell a story of matter heating, swirling, and falling inward on timescales that stretch into tens of millions of years, a process that feels slow by any human measure, yet swift in cosmic terms. One of the fascinating implications of these early active black holes is the role they may have played in shaping their host galaxies. Their radiation and outflows can influence how gas cools, condenses, and forms stars. In some cases, this activity may help regulate star formation, ensuring that galaxies evolve with a balance between growth and stability. In others, the black holes may have spurred rapid early development, clearing gas from certain regions while compressing it in others. They act not as overseers, but as participants in a large-scale collaboration, the galaxy and its central black hole shaping one another through long, deliberate interaction. There is a gentle humor in imagining these early black holes simply turning on one day, finding themselves in a young universe brimming with raw material, and deciding that this was as good a time as any to begin their work. They did not wait for galaxies to finish forming. They did not check whether the cosmic schedule allowed for their early arrival. They simply began, quiet, steady, unconcerned with the expectations of future astronomers. Webb does not portray these black holes as threats or cosmic antagonists. Instead, It shows them as foundational components of early structure, anchors around which matter could gather, engines that help define the architectures of their surroundings. Their immense gravity created pathways for gas to flow, shells to form, and new stars to ignite in patterns indirectly shaped by the presence of these dark, dense objects. As Webb's observations continue, more early black holes emerge from the glow of ancient light. Each one challenges the simplicity of early cosmological models while reinforcing the universe's tendency toward efficiency. Matter collapses where gravity invites it. Energy radiates where physics demands it. And in the earliest moments after the first stars burned, black holes quietly found their places, not as anomalies, but as engines running on cosmic time. They do not hurry, they do not rest, they simply persist, shaping the universe not with violence, but with steady, unyielding presence. Webb, patient as ever, watches them with the same calm attentiveness it brings to every ancient light. Through this lens, the universe reveals yet another truth. Even its darkest objects can illuminate the story of how everything came to be. Light has never been just illumination. It is also memory, encoded, stretched, and etched with the quiet record of everything it has touched. When atoms interact with light, they leave subtle signatures behind, patterns of absorption and emission so delicate they resemble whispers rather than declarations. The James Webb Space Telescope was built to hear these whispers. Its instruments do not merely capture brightness, they parse the fine structure within it, interpreting the chemistry woven into the glow. In this way, Webb becomes not just a telescope, but a reader of starlight, one capable of seeing the universe as a grand chemical manuscript, each spectrum a sentence, each wavelength a clue. At the heart of Webb's chemical sensitivity lies spectroscopy, a technique that breaks light into its component wavelengths. This separation reveals tiny dips and rises, each corresponding to a specific molecule or element. Water, carbon dioxide, methane, ammonia, and a wealth of more complex molecules all leave their unique imprints. In the visible spectrum, many of these signatures hide or blur. But in the infrared, the domain where Webb excels, they come into sharp, unmistakable focus. Here, starlight becomes readable text, and the universe reveals its early ingredients with surprising candor. What Webb finds, again and again, is that chemical complexity began far earlier than expected. Clouds of gas surrounding infant stars contain molecules that seem almost too advanced for their age. Regions of space only just beginning to assemble into galaxies still exhibit traces of carbon-bearing compounds. Even the faint light from distant systems, light stretched nearly to the limits of detectability, carries hints of water vapor or organic molecules. It's as if the universe, in its youthful enthusiasm, began experimenting with chemistry long before structures had fully settled. One might imagine it mixing elements together like an eager cook, adding ingredients before the pot has even warmed. These molecules are not evenly spread. They occupy environments shaped by temperature, radiation, and cosmic history. Webb observes them in the cold spaces between stars, where dust grains act as tiny laboratories. On these grains, atoms bind, rearrange, and sometimes form complex shapes through processes slow enough to defy intuition. These are not swift reactions. They require calm surroundings, long stretches of cosmic quiet, and temperatures so low that motion nearly stops. Yet even under such stillness, chemistry persists. Water forms as hydrogen meets oxygen. Carbon chains build slowly on icy surfaces. Simple molecules join into more intricate structures, each step a whisper of possibility. In warmer regions, near forming stars, the story shifts. Heat releases these molecules from their dust-grain hosts, allowing them to drift into space where Webb can detect them more easily. The telescope sees water vapor swirling around young stars, carbon compounds glowing gently within protoplanetary disks, and nitrogen-bearing molecules lingering in pockets of gas. These signatures reveal that the environments around newborn stars are not barren, but chemically rich, places where the fundamental ingredients for planets gather long before those planets take shape. Some of the most striking observations emerge from distant galaxies whose light has traveled for billions of years. Webb has detected heavy elements, products of earlier generations of stars, far sooner in cosmic history than once expected. Their presence suggests that the universe began forging and distributing complex chemistry with remarkable efficiency. Stars lived and died rapidly in those early epochs, scattering their enriched material into the surrounding gas. Webb captures this evidence in the spectral lines of galaxies located so far away that their light began its journey long before Earth existed. The message is clear. The building blocks for worlds were not late arrivals. They were present from nearly the beginning, waiting for gravity to gather them into structures capable of supporting planets, oceans, and perhaps even life. The telescope's calm interpretation of these chemical clues allows scientists to explore one of the universe's most compelling questions. How common are the conditions necessary for life? Webb does not answer this directly, nor does it search for life itself. Instead, it maps the presence of molecules that precede biology. Water, for instance, appears frequently in Webb's observations, lingering in vapor around young stars and frozen in distant clouds. Carbon-based molecules, essential for organic chemistry, are detected across a wide range of environments. Methane and carbon monoxide appear with surprising regularity. These signatures do not proclaim life, but they hint that the universe set the chemical table early and generously. There is quiet humor in how effortlessly the cosmos distributes these ingredients. Humans often imagine themselves as the culmination of a long, improbable chain of chemical events. Yet, Webb's observations suggest that the universe was mixing, stirring, and experimenting with organic molecules long before planets were stable enough to host oceans. It is almost as though the cosmos prepared its recipes in advance, leaving them scattered throughout space for any world that might decide to try them. Webb's ability to detect these molecules depends on their willingness to reveal themselves through light. Each absorption line, each spectral signature is like a small confession. Yes, I was here. Yes, I interacted with starlight. The telescope reads these confessions without judgment, assembling a picture of a universe filled with chemical possibility. It does not rush to conclusions. It simply listens, patiently, gathering the clues that drift toward it across the dark. In doing so, Webb reveals a cosmos where chemistry began early, spread widely, and continues to evolve in environments quiet enough for complexity to take root. Every molecule detected is a reminder that the universe is more than stars and galaxies. It is also a place of subtle interactions, gentle reactions, and long, unhurried processes that shape the potential for worlds yet unseen. Through starlight, The universe writes its chemical autobiography, and Webb, drifting in the quiet beyond Earth, reads each line with calm precision, uncovering a story far richer and far more enthusiastic than anyone once imagined. When a distant planet crosses the face of its star, the event is not dramatic. There is no flare of brightness, no sudden gesture to announce the moment. The star's light simply dims by a fraction, so slightly that without the right instruments, one might miss the change entirely. But for the James Webb Space Telescope, these small dimmings are invitations. During these brief alignments, starlight passes through the outer layers of a planet's atmosphere, picking up subtle signatures before continuing its journey toward Webb's detectors. In that fleeting moment, an entire world reveals its presence in the thinnest of outlines. Webb's sensitivity to infrared wavelengths makes it exquisitely suited to study these atmospheric fingerprints. Molecules in a planet's atmosphere absorb specific colors of starlight, leaving narrow gaps, spectral impressions of water vapor, carbon dioxide, methane, or other compounds. These impressions are so faint they resemble soft murmurs rather than messages, yet Webb hears them clearly. It separates the starlight into its constituent wavelengths, examining each for the telltale dips that betray the presence of particular molecules. The process feels almost like reading an ancient text through a translucent page. The planet itself remains unseen, a small traveler eclipsed by its star's radiance. But its atmosphere, the thin shell of gases coating its surface, becomes legible. Even clouds, if present, reveal themselves through the way they mute or scatter the light. These measurements do not show continents or oceans or landscapes. They show chemistry, structure, and temperature, all whispered through the filter of passing starlight. Some exoplanet atmospheres appear hazy, filled with particles suspended high above the surface. These hazes soften the spectral signatures, creating smooth, muted shapes. Webb interprets these shapes to understand the altitude and density of the atmospheric layers. Other worlds offer clearer signals. Some show strong water absorption features, suggesting vapor or clouds. Others display carbon-based molecules, hinting at processes shaped by temperature, pressure, or even the star's persistent radiation. The worlds themselves vary widely. Some are gas giants, orbiting scorchingly close to their stars, their atmospheres heated to temperatures that strip molecules apart. Webb detects the motions within these atmospheres, winds racing in high-speed streams, heat transported from day side to night side in a restless cycle of swirling gases. These winds do not resemble terrestrial breezes. They are global conveyors driven by intense stellar light. Yet Webb maps their behavior through tiny shifts in spectral lines, capturing the restless dynamics of worlds locked in unending daylight. Other planets reside farther out, their temperatures lower, their atmospheres thicker and more layered. On these cooler worlds, clouds may form from water, methane, or more exotic substances, silicates perhaps, or iron droplets in the hottest cases. Webb reads these clouds not by seeing them directly, but by measuring how they obscure or reflect certain wavelengths. A cloudy atmosphere tends to flatten the spectral profile, concealing specific molecular signatures beneath broad, gentle curves. It is an atmospheric modesty of sorts, a planetary shyness that still reveals more than it hides. The beauty of Webb's observations lies in their restraint. The telescope does not force conclusions. It interprets patterns. It recognizes that a dip in a spectrum is not just a number, but a hint, an imprint left by gases illuminated and shaped by conditions unimaginable to the human mind. Some worlds may possess inverted temperature structures, with their upper layers warmer than the depths below. Others may experience chemical cycles driven by extreme heat, where molecules break apart on the day side and recombine on the night side, forming a rhythmic pattern that repeats every orbit. Webb observes all of this without judgment, simply honoring each world's unique character. Even the discovery of atmospheric escape, the process by which a planet's upper layers drift off into space, comes through gentle clues. Light from hydrogen or helium reveals outflows extending beyond the planet's limb, carried by heat or stellar radiation pressure. These escaping gases are not dramatic. They leave slowly, silently, unnoticed by the planet itself. Yet their departure shapes the future evolution of the atmosphere, influencing whether a world remains thickly cloaked or gradually pared down to its core. Throughout these observations, one finds a quiet humor in how little attention the planets give to their own discoveries. They orbit, spin, warm and cool, without the slightest awareness that a distant telescope has paused to admire them. They do not pose for Webb or adjust their clouds for aesthetic effect. Their atmospheres filter starlight the same way they always have, unconcerned, unhurried, and utterly unaware of their momentary fame. Webb's measurements hint at the diversity of atmospheric chemistry across the galaxy. Some worlds display signatures of water mixed with metallic compounds. Others show hints of carbon-bearing gases shaped by high temperatures. A few may possess atmospheres so metallic and reflective that they behave like molten mirrors, casting light back into space with a brilliance that complicates observation. Webb navigates these differences with steady precision, treating each world's peculiarities not as obstacles, but as aspects of its identity. In all these studies, one truth becomes clear. Atmospheres are storytellers. They hold records of temperature, pressure, chemical cycles, and stellar influence. They reflect the history of a planet's formation, its migration, and the long interplay between light and matter. Webb reads these records with the calm patience of a listener, seated at the edge of a vast gathering, hearing countless worlds speak at once through faint, overlapping threads of light. And so, Webb reveals the atmospheres of distant worlds not as dramatic spectacles, but as fragile, elegant veils, layers of gas that drift briefly between star and observer, leaving only the softest traces behind. Worlds that will never know they were studied continue on their paths, carrying their atmospheres with them, quietly weaving their chemical stories into the starlight for anyone patient enough to listen. When the universe first expanded from its earliest moments, it did so with a kind of energetic disorder, an immense, unfocused heat filling every direction. There were no stars, no galaxies, no planets, only a sea of particles moving so quickly that any notion of structure was impossible. Yet, as expansion continued and the temperature declined, something remarkable began to unfold. Matter started arranging itself, not through guidance, not through intention, but through the simple logic of physics quietly playing out across cosmic scales. The James Webb Space Telescope was not built to witness the earliest seconds of this transformation, but it observes the consequences, the vast web of structure that arose from conditions once too hot and too dense to allow anything recognizable. Webb's infrared vision captures the story of how matter, given time and space, naturally gravitates toward patterns. Clusters form. Filaments stretch across vast distances. Voids, expansive, silent regions, open like pockets between strands. It is an organization that emerges without a planner, a cosmic architecture built from the bottom up. The earliest seeds of this structure came from small variations in the density of matter, tiny imbalances that would have been invisible to ordinary senses. These differences acted as the faintest invitations. Where matter was slightly denser, gravity held it a little more firmly. Over immense durations, these subtle tendencies became amplified. More matter gathered where matter had already begun to accumulate. Web-like clusters of gas formed, and their gravitational pull gently shaped the surrounding regions. The universe, in its quiet expansion, began laying down pathways that would later grow into galaxies, clusters, and superclusters. Webb's deep field images reveal these pathways not as sharp lines, but as soft glows, galaxies distributed along invisible scaffolding shaped by the primordial density fluctuations. No human hand drew these outlines. No instruction manual guided the flow of matter. Instead, the universe seemed content to rely on natural processes, letting gravity and expansion negotiate a structure that balanced motion and attraction. What results is surprisingly organized. Galaxies arranged in vast, interconnected patterns like beads gathering along threads of an intricate ancient tapestry. This emerging order is not static. It evolves as the universe continues expanding. Some regions cool and condense into galaxies, others spread thin, forming nearly empty voids. Webb sees the results of this dynamic across billions of years, capturing snapshots of galaxies at various stages of growth. Some appear as loose collections of stars just beginning to cohere. Others show the clean symmetry of disks or the soft rounding of elliptical forms. All of them exist because cosmic expansion paradoxically made room for structure to form. As matter gathered into large-scale patterns, regions with higher densities ignited waves of star formation. Yet even here, no central authority dictated the process. Gas clouds collapsed under their own weight, forming stars that illuminated their surroundings. Galaxies grew from these repeated cycles, accumulating more mass each time gravity succeeded in drawing material together. Webb observes these galaxies as evolving systems, some interacting gently with neighbors, others drifting alone across cosmic time. Their shapes, compositions, and motions speak to the balance between expansion pulling matter apart and gravity drawing it together. One of Webb's subtle contributions to understanding this order is its measurement of how galaxies behave at different distances corresponding to different times in cosmic history. Younger galaxies often appear less structured, but even in their youth, they carry hints of the patterns they will eventually embody. Spiral shapes emerge as stars settle into rotational harmony. Elliptical forms arise from gentle mergers. Dwarf galaxies gather like small companions around larger hosts. These formations are not imposed. They arise from interactions and natural tendencies seeded long before any of these galaxies existed. There is a quiet humor in how the universe organizes itself. Leave matter alone with gravity and time, and it builds structures far grander than anything humans construct deliberately. No cosmic supervisor reviews the arrangements. No architectural approval is needed. The universe expands, cools, and simply allows organization to happen. Webb's observations reinforce this sense of effortless complexity, the way a small vibration spreads into a melody, or a ripple becomes a wave without needing permission. The cosmic expansion itself plays a dual role. At large scales, it prevents matter from collapsing into a single clump, maintaining the spaciousness necessary for galaxies to evolve separately. At smaller scales, gravity overpowers expansion, allowing clusters of matter to form stable arrangements. The interplay between these two tendencies, spreading outward and gathering inward, produces the universe we see today, a balance of openness and structure. Webb, positioned far from Earth's warmth, watches this balance unfold across time. It reads the glow of galaxies assembled along filaments shaped billions of years ago, detecting patterns humans could never see without its careful eyes. It observes how structure emerges gradually from simplicity, how complexity builds step by quiet step, and how the universe manages to organize itself without haste, without pressure, and without ever needing to acknowledge the elegance of what it has done. In these observations lies a gentle truth. Given enough time and the simplest of rules, matter naturally finds patterns. The universe does not resist order. It drifts into it. It arranges itself the way frost forms on glass, slowly, organically, without intention, yet with a beauty that suggests a deeper coherence beneath the surface. Through Webb's unblinking view, we see not just galaxies and clusters, but the quiet unfolding of a cosmos that has always known how to build structure from emptiness, one patient expansion at a time. There is a particular quiet that settles in when familiar explanations begin to waver. It is not the sharp silence of alarm, nor the restless churn of confusion. It is gentler than that, a pause, a thoughtful stillness, as if the universe has just shown something unexpected and is now patiently waiting to see how humans will respond. The James Webb Space Telescope has produced several such moments. Its observations whisper details that do not align neatly with the diagrams and equations that once felt comfortably solid. And in that soft mismatch, science finds room to breathe. Theories in cosmology are not rigid statues carved once and left unchanged. They are more like tall grasses, flexible, swaying with new evidence, bending, but rarely breaking. When Webb sends back data that stretches an existing idea, the theory does not shout in protest. It tilts, adjusts, and begins the quiet work of reshaping itself. This adaptability is one of the field's great strengths. The universe is under no obligation to behave in accordance with human expectations, and so scientific thought must remain light on its feet. Some of Webb's earliest surprises arrived in the form of objects that appeared out of place, galaxies glowing brighter or forming earlier than anticipated. These findings were not contradictions. They were invitations. They suggested that assumptions built into long-standing models might require loosening, perhaps making space for processes that had not yet been fully appreciated. Rather than offering immediate answers, the data created a productive uncertainty, a gentle reminder that reality is often richer than predictions. In this environment, certainty shifts from being a foundation to a temporary resting place. Scientists examine the unexpected results not with distress but with curiosity. How did these systems become so luminous so quickly? Why do some cosmic structures appear more mature than anticipated? The questions do not imply that previous theories were wrong, only incomplete. Cosmology, after all, deals with scales so vast that even the most elegant models are still approximations, still sketches of a far greater canvas. Webb's contribution to this landscape is not disruption, it is refinement. The telescope reveals fine details in distant galaxies, subtle chemical signatures in early cosmic environments, and patterns of structure that challenge small features in existing models. These refinements may seem delicate, but over time they gently reshape the broader understanding. It is similar to adjusting the focus on a lens. The scene was visible before, but now the edges sharpen, the background deepens, and new textures emerge. One of the most productive areas of uncertainty involves how quickly complexity emerged after the early expansion. Webb shows that the universe was capable of structuring itself in ways that feel surprisingly efficient. This efficiency does not overturn the framework of cosmology, but it encourages a reconsideration of the timings and mechanisms involved. Perhaps cooling processes worked more rapidly than predicted. Perhaps early matter clumped with greater eagerness, or perhaps multiple processes acted together in ways that had not been fully calculated. The uncertainty is not a crisis, it is a clue. There is a quiet humor in how the universe offers these clues. Webb peers across billions of years, collects photons that have traveled longer than any human timescale, and hands them over as if offering a politely wrapped puzzle. The telescope makes no comment on how the pieces should fit. It simply places them on the table, leaving theorists to lean in and consider. Some pieces join easily, others resist. A few drift into categories that have not been invented yet. And in this slow assembly, the models themselves begin to stretch, their boundaries expanding to include new possibilities. Science in these moments behaves much like a person easing into sleep. Thoughts loosen, rigid lines soften, connections appear that were not visible in the brighter, more structured light of day. This relaxation does not weaken the mind. It invites creativity, the kind needed to reframe an idea or explore a new hypothesis. Uncertainty becomes not an obstacle, but an open door, a quiet hallway leading to an updated understanding. Webb's precision provides many such hallways. Some involve the rates at which stars formed in early galaxies. Others touch on the distribution of mass in distant clusters or the presence of unexpected chemical signatures in systems too young to have formed them easily. Each anomaly is subtle, but taken together, they hint at a cosmos that evolved with gentle urgency, forming complexity faster and more broadly than once assumed. Yet, even as theories adapt, the foundation of scientific inquiry remains steady. The laws of physics do not crumble under Webb's findings, they simply gain new nuance. A familiar equation might require a slightly different parameter. A timeline might shift by a fraction of a cosmic era. A model might expand to include processes once considered too minor to influence the whole. This is not failure. It is progress, unfolding at the measured pace of evidence. Webb's strength lies in its ability to show where models have room to grow. It does not insist on new theories. It simply reveals phenomena that require gentler, more flexible thinking. In this way, uncertainty becomes a companion rather than an adversary. It sits beside science like a quiet guest, offering reminders that knowledge is a journey, not a destination. And so, the universe continues to reveal itself in increments. Some details confirm what was known, others stretch what was assumed. Webb, patient and unflinching, gathers the light that carries these revelations. And in the soft space where theories bend and assumptions loosen, understanding deepens, not through force, but through the quiet productivity that comes when certainty relaxes and lets the cosmos speak. If the universe has a defining temperament, it is unhurriedness, not stagnation and not apathy, just a calm refusal to move faster than necessary. Galaxies turn with the leisure of drifting continents. Stars age at a pace so gradual that their lives span entire epochs. Even the background glow of creation fades with such unyielding slowness that it resembles the cooling of an endless ember rather than the aftermath of a singular event. The James Webb Space Telescope, poised far from Earth's distractions, watches this cosmic patience unfold across distances so vast that time becomes almost a physical presence. Webb's observations show a universe that is constantly changing, yet never in haste. A star forming in a distant nebula may take millions of years to fully ignite. A galaxy drifting into the gravitational influence of a neighbor can spend 1 billion years in the gentle process of merging. Even the faint structures of cosmic filaments, those immense bridges of matter stretching between clusters, shift so slowly that their transformations are measured not by human generations, but by cosmic ages. Nothing about these events demands immediacy. They occur because gravity asks them to, and because time allows them to. One of the striking examples of cosmic patience lies in the evolution of stars. Webb's infrared eyes capture the subtle warmth of protostars and the delicate shrouds of dust that surround them. These young stars take their time becoming themselves. They gather material bit by bit, adjusting their internal balance without drama. When they finally ignite into the long, steady burn that defines adulthood, the process happens quietly. No fireworks, no sudden transition. Through Webb, this slow maturation becomes visible not as a delay, but as a deeply natural pace, the tempo of a universe comfortable with its own enormity. Even the motion of galaxies reflects this gentle rhythm. A spiral galaxy completes a single rotation only once every few 100 million years. That means Webb, in its entire observing life, will see just the tiniest hint of movement in structures shaped over timescales so stretched that human history seems like a brief flicker by comparison. Yet despite their slow turning, galaxies remain vibrant, forming stars, shifting their gas, and interacting with gravity in patterns far too expansive for urgency. Webb also observes the gradual cooling of the cosmos itself. The universe began extraordinarily hot, but it has spent billions of years settling into a calmer state. Radiation left over from the early expansion fades at a rate so steady, so consistent, that its cooling becomes a kind of universal metronome. There is no rush to reach equilibrium. The universe seems content to drift toward it with the tranquility of something that knows it has infinite time. Webb's ability to detect faint, ancient light emphasizes just how long these processes have been unfolding and how long they will continue. Planetary systems, too, develop with this same patience. Protoplanetary disks, those thin, swirling rings of dust and gas around young stars, rearrange themselves slowly, allowing dust grains to collide and merge into larger bodies. These collisions are gentle, sporadic, and often reversible. Planets do not snap into existence. They accrete, drift, adjust their orbits, and occasionally reset their progress entirely. Webb sees these disks glowing with soft infrared signatures, revealing gaps and rings formed over millions of years by the quiet choreography of gravity. It is a reminder that even worlds take their time becoming worlds. There is a subtle humor in how unhurried the universe remains, especially compared to the frantic pace at which humans often measure their days. Deadlines, calendars, and clocks have no meaning to galaxies. Stars do not rearrange their schedules for convenience. Nebulae do not feel late or early. They occupy whatever stage of development physics has assigned them. If the universe were capable of commentary, it might gently suggest that rushing rarely improves the outcome of anything. Webb's vantage point allows it to see the cumulative results of this patient cosmic behavior. When it looks at galaxies far away, it sees them not as static portraits, but as snapshots taken at different stages of an enormous unfolding. A galaxy forming stars vigorously in one era may appear serene billions of years later. A cluster, assembling through gentle mergers, eventually becomes a stable structure containing thousands of galaxies. Each observation is a moment in a process that started long before the telescope existed and will continue long after its mission concludes. Even cosmic expansion, the steady stretching of space itself, moves at a pace that defies intuitive experience. It is relentless, but not hurried, shaping the separation of galaxies inch by cosmic inch. Webb's measurements of distant objects reflect this expansion not as an abrupt change, but as a consistent, gradual shift in the light they emit. The redshift Webb detects in ancient galaxies is not a dramatic distortion. It is the accumulated effect of billions of years of space quietly stretching itself. In this slow-moving universe, patience is not simply a virtue. It is a fundamental operating principle. Nothing is wasted, but nothing is rushed. Structures grow because they have the time to do so. Energy disperses because the universe allows it. Patterns emerge not from quick decisions, but from the quiet persistence of physical laws unfolding at their natural pace. Through Webb's gentle gaze, the universe reveals itself not as a place of sudden events, but as a landscape shaped by steady transitions. It evolves with the calm assurance of something that has never once felt the need to hurry. Stars mature when they are ready. Galaxies meet when gravity brings them together. Light takes its time crossing the void, arriving precisely when it can. And in witnessing this unhurried grandeur, we are reminded that the cosmos moves at a rhythm far slower and far steadier than our own, a rhythm that continues with or without our awareness, carrying everything forward in its patient, measured way. Of all the observers in the cosmos, humanity may be the most unlikely, not because the species lacks intelligence, far from it, but because its perspective is so modest. A small world circles an ordinary star, wrapped in a thin shell of breathable air and illuminated by a sun that is neither young nor old, neither exceptional nor forgettable. And yet, from this quiet vantage point, humans have developed the peculiar habit of lifting their gaze toward the night sky, noticing faint glimmers that have traveled for unimaginable spans of time, and wondering what they might mean. The James Webb Space Telescope represents one of humanity's more ambitious attempts to extend that wondering beyond the limitations of the human eye. It is, in a sense, a tool designed to amplify curiosity. Positioned far from Earth's noisy atmosphere, Webb acts as a listener, catching ancient photons that whisper stories across space. But while the telescope floats in cold darkness, the species that built it remains on the warm, shifting surface of a living world, observing from a place filled with weather, oceans, forests, and the constant hum of daily life. There is a quiet contrast in this arrangement, a high-tech observatory shaped by a species that still pauses to admire sunsets, still steps outside to look for shooting stars, still names constellations after animals and myths. Humans are not the dominant actors in the cosmic stage. They are quiet spectators, leaning back in chairs, lying on blankets, and watching light that predates their entire civilization. Their relationship with the cosmos is not one of control, it is one of gentle curiosity, an instinct to ask questions even when the answers may require lifetimes to arrive. When Webb sends back images or spectra, the information travels to a world busy with its own concerns. Cities glow at night, seasons turn, and people go about their days largely unaware that ancient light is being interpreted just above their heads. But somewhere, often in quiet laboratories, observatories, or living rooms late at night, someone pauses to look more closely. They adjust their glasses or their posture or the brightness of their screen, trying to take in the significance of what Webb has seen. The world around them remains warm and familiar, but for a moment their thoughts drift to distances so vast they stretch beyond language. Humanity's habit of wondering is particularly interesting because it demands no immediate reward. Curiosity survives without urgency. There is no practical need to understand galaxies billions of light years away, no pressing requirement to know how early stars formed or what molecules float through distant planetary atmospheres. And yet humans pursue these questions with steady enthusiasm, as though understanding the universe offers a kind of nourishment, calming, grounding, and strangely comforting. One might say that humans practice a form of cosmic eavesdropping. They listen to light that has crossed the void without expecting applause or acknowledgement. They watch faint pinpricks of brightness with the same quiet reverence one might bring to a slow, familiar melody. Webb amplifies this experience by revealing details too subtle for direct vision. It shows the universe not as a series of unreachable objects, but as a vast landscape of ongoing stories, stars forming, galaxies merging, molecules drifting, and invites humanity to observe without hurry. There is a warmth in this relationship, an intimacy even. Humans, for all their restlessness, are capable of extraordinary stillness when looking at the night sky. They do not need to travel through space to feel connected to it. A comfortable spot on a porch, a rooftop, a patch of grass, or even the light glow of a computer screen late in the evening offers enough of a vantage point for the mind to wander beyond its usual boundaries. In these moments, the species appears almost contemplative, letting its thoughts stretch outward like gentle ripples across a lake. Webb's discoveries reinforce this sense of quiet companionship between humanity and the cosmos. Ancient galaxies, faint stars, drifting exoplanets, all send their signatures to Earth, where humans interpret them with instruments, equations, and long discussions carried out over coffee or in the dim glow of conference halls. There is nothing rushed about this process. Scientists know that understanding unfolds slowly, sometimes over decades. They accept this pace, perhaps unconsciously mirroring the universe's own preference for gradual evolution. And yet, amid this calm, a subtle humor arises, The universe, expansive and indifferent, reveals its secrets in the faintest traces of light. Humanity, small and often preoccupied with mundane concerns, reacts with delight. Publishing papers, presenting findings, or simply sharing images with friends, a galaxy that formed billions of years before humans existed becomes, for a moment, the topic of conversation over breakfast. This mismatch in scale does not diminish the experience. It enriches it. The cosmos offers a quiet nod, and humanity answers with curiosity. From their one small orbit, humans also carry an instinctive sense of humility. They know their world is not the center of anything except their own experience. Yet this realization does not lessen their fascination. It deepens it. To be small in a vast universe is not discouraging. It is clarifying. It inspires a sense of belonging that comes not from dominance, but from participation in a system far grander and older than anything humanity could build. So humans continue to listen. They send telescopes outward, not to conquer space, but to observe it with a calm and steady interest. Webb, drifting at its distant post, captures ancient light and sends it home, where it lands softly in human minds, inviting wonder, reflection, and a quiet sense of connection. And in this gentle exchange between a vast universe and a small, inquisitive species, one truth stands out. Sometimes the most profound discoveries are made not in moments of urgency, but in the stillness of contemplating the stars. While the world turns slowly beneath you, there is a quiet irony in the way the universe behaves under closer scrutiny. Most things, when examined in detail, reveal order or logic that helps to dispel uncertainty. But the cosmos, viewed through the James Webb Space Telescope, seems to drift toward the opposite tendency. The sharper the resolution, the further the gaze, the more the universe expands its repertoire of peculiarities. Familiar ideas blur at the edges, expected patterns soften, and yet, instead of creating alarm or confusion, this strangeness settles over the mind like a calming mist, gentle, cool, and unexpectedly soothing. The deep fields Webb produces, those images filled with faint galaxies stacked by the thousands upon thousands, do not offer clarity so much as a widening sense of scale. Structures that once seemed orderly reveal unexpected diversity. Regions thought to be simple turn out to contain layers of complexity. Even empty space begins to shimmer with subtle background glow, as if reminding the viewer that nothing in the cosmos is ever truly vacant. These layers of unexpected detail do not overwhelm. They slow the mind, inviting it to expand just enough to accommodate the possibility that not every question must be answered immediately or perhaps at all. Webb's observations often contain curiosities that sit comfortably outside established explanations. A galaxy brighter than models predict. A star-forming region more efficient than physics seems to permit. A distant structure arranged in a way not easily categorized. Each anomaly is quiet, never announcing itself loudly, but it lingers with a kind of cosmic politeness, as if to say, I exist, and that is enough for now. The universe, when confronted with these uncertainties, does not try to correct them. It simply continues drifting forward, offering no hint that it feels obliged to tidy up the confusion. As strange as these findings are, they carry a remarkable stillness. The mysteries Webb reveals do not burst forth with urgency. They unfold with the gentle confidence of something that has existed long before questions were asked. Even the most puzzling structures appear unbothered by their own contradictions. They shine They drift, they evolve, unconcerned with the interpretations offered by distant observers. In this way, the universe feels less like a riddle to solve and more like a landscape to wander, expansive, quiet, and unconcerned with providing directions. This sense of calm mystery becomes particularly clear when Webb peers into the earliest ages of cosmic history. There, the universe adopts an almost dreamlike character. Galaxies appear at unfamiliar shapes and sizes. Light bends in ways that hint at unseen structures. Patterns resemble sketches half drawn, suggestions of processes not yet understood. And yet, everything moves with such deep patience that the strangeness feels soft, almost reassuring. Nothing is forced. Nothing is abrupt. Even the surprises arrive without sharp edges. There is a gentle humor in the universe's refusal to simplify itself for human comprehension. It does not clarify its workings, nor does it disguise them. It simply offers observations that stretch the imagination, then continues along its timeless path without waiting to see whether its meaning has been deciphered. Webb's instruments, finely tuned and immensely capable, catch these cosmic hints like scattered notes drifting from a distant song, interesting, beautiful, and never quite forming a complete melody. This incompleteness is not a flaw. It is part of the universe's charm. The cosmos remains vast enough to include phenomena that resist categorization, phenomena that seem to say, "You may understand some parts of me, but not all," and that is perfectly fine. The openness of these mysteries encourages a slower, more reflective engagement with the universe. Instead of striving for immediate answers, the mind is invited to rest within the unknown, to drift alongside it rather than chase it down. The peace found in this uncertainty has a grounding effect. In a world where so much energy is spent seeking resolution, it is strangely comforting to encounter something that does not require solving. Webb's images suggest that the universe has never been in the business of offering tidy explanations. It offers experiences, soft glows, ancient light, drifting patterns of existence, and leaves interpretation as an entirely optional pastime for whichever species happens to be watching from one small orbit. And beyond all the complexity, beyond all the strangeness, lies the simplest truth Webb continues to reveal. The universe does not worry. It does not fret over the oddness of its early galaxies or the peculiar behavior of distant stars. It does not apologize for being difficult to categorize. Its mysteries do not stem from indecision, but from abundance. Too many possibilities, too many pathways, too many eras of development intertwined across unimaginable distances. The cosmos is strange because it has had so much time to be anything it wishes. In the end, the deeper Webb looks, the more the universe resembles a quiet companion, content to share glimpses of its vastness without demanding comprehension. Its strangeness does not diminish its beauty. It enhances it. Each unanswered question becomes another soft contour in an infinite landscape, another distant glow in the dark that invites thought without insisting on it. Mystery, in this cosmic sense, becomes a kind of rest. Not a barrier, but a place to linger, a spacious uncertainty in which the mind can loosen its hold on explanation and simply breathe. And the universe, expansive and serene, seems entirely at ease continuing this way, softly glowing, endlessly unfolding, calmly strange, and in no rush at all to be understood.